All right, so here we go. Word problems with right triangles, little mini lesson. So we have the angle of elevation and the angle of depression. When you elevate something, it's going up. So if your person is right here looking up in the sky at something, this angle here is the angle of elevation. Okay? If up here, like looking down at something, like being on a mountaintop and looking down, this right here is the angle of depression. All right? So we have a word problem, which we're going to be working on. At point A, so here's point A. This is where the person is. If you want to put a little person, go ahead. 123 feet from the base of a flagpole. So you're standing 123 feet away from this flagpole. The angle of elevation is 26 degrees. So you're given the angle. Find the height. So from this person, we notice we do not have the hypotenuse. Okay, we don't know what it is. So if we don't have the hypotenuse, we must have opposite and adjacent. This is our opposite. This is our adjacent. It's a good idea to label those just to remind yourself, which means we know we're doing tangent. We do have an angle, so we're going to say tangent of 26 is opposite, which is just a letter. No, that's not a 9, it's an A, over 123. Now, we've already talked about how to solve these. This goes back to basic algebra. If we had a number equals x over 5, we would multiply by 5. We're going to do the same thing here, except we're going to multiply by 123. That cancels here, and you type in your calculator, which we've already done this, but you literally just type in 123 times tangent 26. Remember, if you do it this way, the parentheses really doesn't matter. If you typed in tangent of 26 first, you definitely have to close the parentheses before you say times 23. And you get 59.99. So when we're talking about angles, we can go ahead and just round to the closest whole number, about 60 degrees. It's approximately 60 degrees. Okay? This is nothing new. It's just translating a word problem into what we've already done in the previous lessons. All right? So from the top of a 210-foot cliff, so you're standing up here on top of the cliff. That's a really weird person. All right? They observe a lighthouse, which is 430 feet away. Now, again, we don't have the hypotenuse, so this is a tangent problem once again. From this person, we're looking to the opposite. So tangent, we don't know the angle. So we're just going to say tangent of A. We don't know it, and this is what we have not learned how to do yet. Is opposite, go ahead and label that, 430 over adjacent, which is 210. Once again, we have no hypotenuse number. That's why we're doing a tangent. Now, we don't know how to do this yet. We've calculated one of the missing sides knowing the angle. So we got to do this a little bit differently. We're still going to do tangent, but we're going to do what's called an inverse. So if you look above the tangent in blue is negative tangent -1. So we're going to hit second tangent on your calculator. You hit second, then the tangent button. We're always going to hit the second button when we're trying to find the angle. And now you just type in this fraction, 430 divided by 210. Close parentheses if you want, not a big deal. And that's 63.97. So again, we're just going to round, estimate approximately 64 degrees. It's about 64 degrees. Let me go back real quick and check something. I made a mistake here. I don't know what I was thinking. We weren't calculating degrees here, so that was silly of me. So we were calculating the measurement. So this was feet, about 60 feet, not degrees. I was getting ahead of myself. I apologize. All right. And the last example. Now we don't have a picture. This time we're going to draw our own. And we're going to bring our best artwork into it. So we're going to have a ground. We got a ladder and a wall. So here's my wall. Here's my ladder. Just, it's wonderful. If you want to put little things on it, look at that great drawing. So the top of a 7-foot wall. So this is 7 feet here. Okay? At the bottom of the ladder is 4.5 feet from the wall. Now you can tell I already did a bad job drawing because this side looks longer. It doesn't matter. If you wanted to draw it to scale, you could really be better about it and do something like this. And oh, that's 4.5 and that's 7. It doesn't really matter. I'm not grading you on the drawing. What's the angle between the ladder and the wall? Okay. What is the angle of the ladder and the wall? Now you got to be careful. It says the ladder and the wall, not the ladder and the ground. So the ladder and the wall is here. So that is an angle of depression. And why that matters is from here, this is opposite and this is adjacent. If the problem said the ladder and the ground, then 7 would be opposite and 4.5 would be adjacent. So it really matters where you're looking from. And we're looking from up here, the ladder and the wall. So we're trying to find the angle. Again, we have no hypotenuse. So this is not a sine or cosine problem. It's just tangent. But if we had the hypotenuse, we'd be using one of those. So tangent of, you can just call it x or a, whatever you want. It doesn't matter. Is opposite over hypotenuse. So we go to our calculator and we're going to hit second tangent because again, we're calculating the angle. And if we were doing sine, we do second sine. If we're doing cosine, we do second cosine. It's that simple. And then you just type in 4.5 divided by 7. Enter. And we get 32.7. So we can go ahead and round that to about 33 degrees. And that is it.